Hey folks, so in the last video what we saw is that it's not sufficient to use kind of a naive BFS or DFS approach to check to see whether there's a cycle. It's simply not enough to know that seeing something that's already marked indicates a cycle, right? And we've seen the counterexample of that. So what can we do instead? So up here I have my example of a graph that doesn't have a cycle in it, right? And that's the one that gave us trouble. Okay, so that's one issue. What we do want to be able to find, though, is maybe something like this, right? So this is going to be a graph that I'm intentionally putting a cycle into it because it's something I want to somehow detect, right? So I have still the same letters, but this time I'm going to go A to D, D to C, C to B, right? So I should find a cycle in this one. So here's the overall intuition or the overall thought. If I want to find a cycle, right, what I want basically is to show that I run into myself, okay? So what does that mean? So let me draw a picture here. Actually, I'll switch colors really quick so we can do a little bit of an overlay thing here. Like here. So I'm starting at A, right? I go down A, I go around C, and somehow I bump into myself, right? So I have a path here, right? I had to pass through basically B, right? If I bump it into myself, then that indicates there's a problem, right? So maybe I have a little mini picture over here, so I have A over here, right? A needs to basically go down, do some stuff, and then end up hitting itself. Right? This is the way I can find a cycle in a directed graph, right? So I can't just run into a particular node that was marked somewhere else, right? So here, right, if I maybe do another sketch over here, somehow what this other problem looks like is it's like, well, maybe I went to here, right, and then I backed up, and then I start over here. Well, if I start over here, right, I shouldn't count like that, right, as a collision, because this one over here, right, if I was going that way, right, let's say I went out initially from that A, right on the left-hand side, so I went out. Then it's like I got stuck, I had to backtrack to A, I went out again. If I collided with this one, right, it's no good because the direction doesn't lead me back to A, right? That was the problem we had overall with this first graph over here. So this is no good, right? I don't want to collide with basically another attempt to explore the graph. Instead, what I want to do is collide with myself. I want to be exploring the graph and then see myself again, right? So that's this picture over here, right? So A, right, goes and explores the graph. It's almost a little bit wacky there, but A is going right, and you can picture this line is going through different nodes. And I want to make sure basically that I run into myself, right? Am I colliding with my own path? If I am colliding with my own path, well then everything is good, right? So actually I'll expand this out a little bit. So let's say we go, right, A does some stuff, right? And eventually you go to node X, right? You go out of X, right? You have this other path, right? Let's see, just squiggly lines for like there could be other stuff in there, right? And I arrive back at X. Right, this is good. This is actually a way we can find a cycle, right? So look at this picture here, right? I would have the following information. I would know that X is connected to A, like this, A goes to X. And then I would actually find out, right, that if I collide with myself, it looks then like, X is connected to X somehow, right? If I have this little collision here. And actually, maybe I can make it even a little bit more clear. Yeah, I'll back that up a little bit. Let's add in one other node maybe to illustrate it a little bit better. Let's back that up. Okay, so let's say we have here another one. So we'll say we have Y over here. Then some stuff, some X, right? And then maybe X circles around and hits Y, right? Well, in this kind of picture here, right, I know, right, A is connected to X, Y is connected to X, X is connected via some set of things, right? I'll put the ... to Y, right? In this case, right, I have the three things, right? I go from A to X, and then from X to Y via the bottom rule, and then from Y back to X, right, via the middle rule. Okay, so in this case, right, because I'm basically colliding with myself, right, the same path that I took to get to X, right, I'm colliding with that path, right? So I'm in my graph, right, I started at A, went through Y, some other stuff, eventually I'm at X, right, I come out of X, and I swirl around, right, and somehow touch Y again, right, which is on the path that I took to get to X. That implies there's a cycle, right, if I run into myself, right? The simplest possible diagram is something like this, right? It's like A, you go out of A, and basically you swirl around and you hit yourself, right? That's a problem there. So this is going to be our basic mechanism, right? Is we want to basically keep track of the path that we took to get somewhere, and so if a node is marked and it's on the path that we took to get there, then we run into a cycle. That's going to be our rule. Okay. So how would this look for this thing over here? We'll try kind of running a little bit of an example. What I'm going to add basically to both these pictures is a stack, because that'll let us kind of track what's going on. So let's say I'm doing DFS, right? This is actually the reason why I started with DFS. Let's just see what happens, right? So we're going to use the following rule. There is a cycle. Well, we find a cycle if during a DFS search we not only see a marked node, but we see a node that was marked on the path we took to get to the current node we're exploring out of. Okay? So let's try this. We start over here. We initially see A, so we maybe put A on our stack, and we start doing our little path, right? Then we go to B. Okay, B is good. We put that on our little stack, and we go and look at C, right? So we go down to here, right? C goes on our stack. And then we're stuck, right? We don't have anything to do, and so we actually erase C from the stack, right? We back up, and now we're back at B all of a sudden, right? This goes away, right? And we're back at B. Actually, maybe I'll update that a little bit. Back at B, and then we go to D, right? And D gets pushed on the stack, right? And we see we have D there, and then we see C. C is marked, but it's not on the path, right? The path I took to get to C when I saw it being marked was A, B, and then D, right? But I didn't get to C via C, so everything is fine. So this looks good, right? We see a marked node, but we don't say there's a cycle because that node we ran into C isn't on the path we took to get there, so everything is fine. Now for the right-hand one. So I have A, B, C, D again. So I maybe start my stack again. I start with A up top. I go from A to B. Okay, that's fine. B to D. So D goes on here. Then I go to C, right? And these are all getting marked, right? I should have marked the other ones as well, right? These are all marked as I go through there. Marked. These are all marked internally. So I go A, B. I lost the letter here. A, B, D, right? And I keep on going. I go to C. So C gets pushed on the stack. And then, right, from C, I go out of C, and I see B. B is marked. Maybe I'm concerned. And B is in my stack, right? So I run into myself, right? So this is the path I took to get there, right? So internally, right, I basically went from A, B, D, C, and then I went back to B, right? I bumped into myself, right? I have that picture there where I went exploring and I ran into myself, right? That's what I see. That's what implies there's a cycle, because now I can go like this, or I can just go like that indefinitely, okay? So I have hit a cycle. So that's going to be our rule, right? We want to basically check to see, do we collide with ourselves? If we do collide with ourselves, then it is indeed a cycle. So that's going to be our expanded rule for finding a cycle in a directed graph.